Welcome back to physics related movement inside of Armory 3D. Previously talked about pixel per frame movement that is consistent. Now let's talk about physics related movement, because physics can be random, can be chaotic. So to activate physics inside of Armory 3D, you need to add a rigid body component to an object. So you can do that by going to the physics tab or using the logic node. You can add a rigid body logic node and there configure all the different rigid body settings that we want. But for now, let's go ahead and leave all those settings as they are, and let's just focus on the logic nodes to move an object around. Now what we're going to do is we're going to add a keyboard event to trigger our nodes to move the object, and obviously go ahead and grab an apply impulse node. Now this apply impulse node is essentially going to project our object in whatever direction we want. For example, 1 on the positive Z axis. And now we're going to jump upwards every time as we're falling in the negative Z axis and we're pushing against the gravity with a positive impulse. To apply something similar but different, we can apply a torque. Now, a torque is essentially the same thing as an impulse but for rotation. We can do the same thing, add a value onto the Z axis, and now it's going to rotate anti-clockwise on the Z axis, but only on the Z axis, because this isn't physics related. Right now we've got no objects that we're colliding with, so the movement is all based on the logic node. So we can add some randomness to it to make it seem more random, but it's really all controllable, it's all coded in. So it's a great way if you want to have more control over the look and feel of your object. But we can go ahead and do something different. For example, add a force. Now the difference between a force and an impulse is rather small. It's basically the same thing, it's just how and when to use the different ones that is important. A force is more consistent. It allows you to do things to simulate things like gravity or air resistance and things of that nature, things that are more long term, whereas an impulse is instant. Every time that you run an impulse, it is a single burst of energy, so it's great for things like bullets or jumps and instant speed ups and things of that nature. We can control things like the friction and bounciness of an object in the rigid body properties, and that essentially controls how slidey the object is and how bouncy it is. But we can also do things like controlling the dampen translation and the dampen rotation, that basically controls the object fall off of the movement and the rotation of that object. So as a result, if we want to make the object slide less, then we can increase the dampen translation and the friction. But you may have noticed we have multiple nodes, like the apply force at location and the impulse at location node. So this essentially allows us to control the location that the force is taking place instead of being the origin of the object, because that is the default. So here -5 is pushing the object from -5 upwards, so it's pushing the object into the air. So this essentially gives you a lot more control, and as a result now we can control things like the rotation of the object, because as you see it's rather chaotic, that rotation. So you can go down to dynamics and clamp the rotation of the object, and this makes it seem less, well, like a fidget spinner. Some of the main values that are the most important to influence the movement of an object, mainly for the falling, is the world gravity, but also the object's mass. If you want a heavier object, then increase the mass of the object. You can also do this with nodes by using the add rigid body node and increasing the mass of that object. And finally, let's talk about the Armory properties in the rigid body tab. Down here we have a bunch of options, including the trigger checkbox. And this essentially means that if you apply this to an object, for example a passive object, it's not going to apply any physics if an object collides with it. It's going to go right through it as if there's no collisions whatsoever, but it's still going to send out that collision event to your code, so you can do stuff with the code. We also have a bunch of properties to control the movement, for example the linear factor and the angular factor, but all of these properties are available and can be used in the set rigid body velocity node. And as you can see, it's the same option, except we also have a linear added here. And the linear is essentially the same thing as an impulse, except it's consistent. The impulse fights against forces like gravity, so when it falls and you press your event key, it's going to apply force, but it's not going to be the exact same amount of force as previously, because it's fighting against the gravity, so some of that force is worn off, whereas a linear velocity is going to boost the object the same distance every single time. And this can be very useful if you want a game mechanic where that needs to happen. If you have a game mechanic like a Flappy Bird mechanic where it boosts sometimes a distance of like 20 pixels and then sometimes only 5, that's a big problem. The linear factor essentially serves to limit what a movement is allowed in what angle. So you have obviously the different axes X, Y and Z, and if you limit all of these to 0 except for the Z, then all your movement is only going to be allowed to happen in the Z axis. It's not allowed to move on the X or Y. This is great if you want to do something like a 3D side-scroller game where the object's not allowed to move off of this linear path, so it's not allowed to go onto the X or Y axis, it's only allowed to go up and down. However, you can also just control the influence, so instead of setting it to 0 as in turning off the movement on that axis, you can set it to a smaller number so it's less likely, but it's still possible to move on those axes. Thank you so much for watching this video and understanding hopefully physics related movement inside of Armory 3D. I'll see you next time.